Hello everyone, my name is Rajesh Kumar and I'm your Devops SRE DevSecOps coach. So today we are going to learn Kubernetes. Um, as part of it, we are going to understand what is Kubernetes architecture. We are going to install the Kubernetes. We are going to work with the pods, deployments, and services. So these are the things we are going to do that. So what is Kubernetes? So in order to understand Kubernetes, we need to understand four fundamental questions. Where did it come from? What does it mean? What does the name mean? What does it do? And why do we have it? So, guys, Kubernetes is born in Google, and Google donated this product to CNCF. So, CNCF is one of the largest organizations, something like a new generation of Apache, you can say. So, Kubernetes became open source in 2014. This product is written in Golang. Source code you can find on the GitHub. Some of the websites like kubernetes.io, Slack channels, meetups groups, and many more. So now where did it come from? So if you try to understand the Kubernetes, then you need to understand the Bog and Omega. Let me tell you here, container technology is not something new. It's been there since ages. Many data center company they were using container technology in a different way, but because of Docker, it's become a very popular because it's become handy for the everyone actually. So if you look at the Bog and Omega, this is the one of the product proprietary one from the Google, and they were using this product to manage their infrastructure. Yes, the infrastructure which you see, which is highly reliable, highly scalable, no performance issues, and it's running 24/7. So you see that they're all running on the Bog and Omega. So something similar, Kubernetes also can do that. So I'm not saying like Kubernetes is coming from the Bog and Omega. I mean, that means it's the next version of Bog and Omega. But because Kubernetes has something similar capability and same time they all are coming from the Google, so we say like a genes are matching, DNA is matching, right? DNA is matching, something similar. So in short, we call it a KEPS. This name has been taken from the Greek dictionary, which is called Helmsman. Helmsman, the meaning of the Helmsman, the person who steers a ship. So here the idea of the Kubernetes can steer a ship. For example, let's say if your size of the ship is small fishing boat or the large ones, shipping vessels or aircraft carrier, still that is handled by one person, right? That is controlled by one person. Same way, the no matter what is your the size of data center, uh, how many nodes you are running, uh, uh, you know, so that whole things still that Kubernetes can manage it. That is the beauty about it. So yes, this is the introduction about the Kubernetes. Now next questions you will ask, why do we need it? So guys, last day we learned Docker, and Docker we understood the containers also. Some of you have tried also for that. So containers bring scalability challenges. Think about the data center. You do not want to run everything in one host. You want to run in thousands of hosts. Scale, you want it. Scale up, scale down, you want it. Why you want it? That's I assume you all understand that. Why do we need to run lots of application in a multiple server rather than on one? Reliability, scalability is a concept. Now, you know the Docker, right? Yesterday, I mean, last session we installed the Docker, and then we found out whatever the Docker, it manages the resources of server. So using the Docker, you can run as many containers you want it. But if you want to scale the Docker, you have to have a second Docker, third Docker, fourth Docker in a different host. So that's okay. But the question is, who will manage so many Docker hosts? Because in a data center, you have thousands of server. How can you manage it? So the moment you try to bring those containers in your production, you want to run at the large scale. And that is where the challenges is coming in terms of Docker. Containers bring scalability challenges because containers run on the host. And we are starting to view the data center as a one computer. So if you look at this here, this is architecture image for Docker. If you look at it, this image carefully, Docker manages the network, containers, image and volumes. We understand that. Yesterday I told you last session, Docker manages all these resources. Now, if you look at the architecture, this one, other way, Docker client, send the request to Docker daemon talk to kernel, and then Docker daemon get the images from the hub and then create a container with the kernel. So this we understand that. So now the problem is, let's assume, let's say you in a production, you want to run 15 containers. Now the limitation of each containers are, each host are, you can run maximum 3 containers in a each host. Then what do we do in this case? Then you will say simply, nothing great about it. Run the 5 VMs, 15 containers, it will become 15 containers. That is fine. But the question is, who would manage multiple Docker hosts? In this scenario, we have only 5. What about thousands of server where you want to run a Docker, and then who will manage it? See, containers bring scalability challenge. The moment you start scaling, then you start getting the challenges. How do we solve it? Now, guys, last session, if you remember, you were not able to expose to Apache at the same port of the node. If you remember -p options we were using, at the node port, you can only expose only one container. So the question is, what is the use of it? Because you know that load balancer need to be there in the production. Load balancer works on the different IP, same port number. Load balancer is always running outside, right? So they have a different need to be different IP and same port. But let's say in this case, what is happening? Let's say you have a multiple containers, you're exposing to the host, it'll become a same IP but different port number. That is against the load balancer rule. You see that? So the question is, okay, running is one challenge. Second one is how to load balance multiple containers with the same port in one host. Because if you do that, your load balancer will not work. Are you understanding, all of you?
Yep.
Yep. Now, guys, here one more challenges. I'm just trying to help you to visualize a high level few challenges. There's so many. At the current stage, the Kubernetes provides so many features. It's like ocean actually now. Everything you can find in the Kubernetes. Here, if you see, in order to maintain the response time of your applications, that means user experience should be good, digital experience should be good for your end user. You want to run 15 container at any given point of the time. Now let's say midnight, 4 o'clock, suddenly when we all are sleeping, suddenly 2 nodes got down. It can be any issues, I don't know, hardware issues, network issues, software issues, security issues, it can be anything. 2 nodes down, 6 containers are not working. That means entire load you have at 9 containers. That means what will be the results? The response time of applications will be high because people will complain about the slowness of the application. So now what will happen? P1 will be calling P2, and then multiple people will be in a war room. They will try to solve this problem, this, that, and easily it will take 30 minutes or let's say 1 hour. Now you know that 24/7 we are expecting everything to be up and running. So how can you make sure that whatever we specify, let's say we need a 15 containers at any given point of the time, 15 containers should be running. If some of the containers are not working well, then we should immediately, I said immediately, should replace with the new containers. So that is the thing. Who will do the auto healing capabilities? We need 15 containers at any time, but 2 nodes are down. How to do auto healing? Do you have any capabilities? So this kind of challenges you will have once you introduce the container in the production. I repeat, introduce the container technology in the production, and that is where we need some solutions. So now, guys, we know that data centers, we have hundreds of CPU, RAM, storage rack, this, that, and all. So we need a one software which can view entire data center as one computer and deploy as you deploy the Docker with the Docker in a one host. So who can do that? And that is where the Kubernetes is coming into the picture. Kubernetes can manage it. Kubernetes can help you in all the challenges which you are experiencing, introducing the containers in the production, and all this thing will be done by Kubernetes. Kubernetes will help you in terms of networking challenges. Kubernetes will help you in terms of orchestrating challenges. Kubernetes will help you in terms of health check. Kubernetes will help you in terms of you know uh, uh, deploying the containers in a multiple host, and everything it will help you. So now at least little bit of the context you got it. Why do we need it? Kubernetes. All of you. Hello.
Yes, yes.
Yeah.
Yes.
Okay. Yeah. So guys, it's all about the pets versus cattle. What does that mean? So guys, when you are in a Kubernetes session, think about the cattle business owner. Do not think about the you are owner of some pets. Why? Because pets, you play with that, you take care of that, you feed them. Something goes wrong, you fix them. All this thing you do that. But let's say some of your cattle are not functioning well. What do? Would you say to your customer saying that, hey, my some of my cattles are not good, working well, so I will not deliver the milk, let's say 1,000 liters of milk daily. I will deliver after 1 month. Do you think this is the right way to do the business? Are they going to listen? No, of course. You committed 1,000 liters of milk daily, it has to be delivered. So what you will do? You will replace the cattle who's functioning with the cattle which is not functioning. Simple. So now here something similar in the production you have to build your mindset. You are running thousands of applications. Some of the applications are not working well. So you cannot say like, okay, I'm not going to, you just hold on. We're working on it. It should be automatically replaced with the new applications. Ultimately, let's say you want 1,000 instance should be up and running. Applications should be up and running. So that kind of platform which is being given by Kubernetes. Okay. So when you are learning Kubernetes, main objective to run thousands of containers in a cluster. If some container is not working, Kubernetes will replace with a new container to make sure actual number of containers must match with the desired number of containers. So that's the work which Kubernetes will do that, but you have to set your mindset as well. So what is Kubernetes then? So guys, Kubernetes is a container orchestration. I must tell you here, Kubernetes is not only the container orchestration. Kubernetes is a container orchestration, Kubernetes storage orchestration, Kubernetes is a microservice orchestration, Kubernetes service orchestration. Many features you have Kubernetes, but primarily this is the major feature, container orchestration. That means if you want to run container in the production at the high scale, Docker will not help you because Docker can manage only one host. Kubernetes can help you. Okay. Kubernetes is having the workload placement also. What is workload? Workload is your containers. The guys, the moment I say work means container. Workload means the place where you are running a container. Okay, so Kubernetes is also doing the workload placement. That means out of 100 nodes, which nodes I want to run the containers, Kubernetes can decide. Kubernetes also can help you in terms of infrastructure abstraction, networking challenges which are highlighted, right? Load balancing issues. Kubernetes will help you without you getting into the in depth of it. Kubernetes will also help you in terms of managing a desired state. Desired state means you said I want 15 containers at any given point of the time. Kubernetes at any cost will make sure that 15 containers is running up all the time. If some 10 containers are not running, they will replace with the new containers. Who will do that? Kubernetes will do that. So this is the Kubernetes. Kubernetes has a self-healing capability. You can automatic rollout, rollback. You can do auto scaling also. You can have a load balancing also, and many things. Some of the benefits of the Kubernetes like speed of deployment. You can deploy thousands of applications within a seconds. You can update that thousands of applications within a seconds. You can roll back thousands of applications within a seconds. and all this complexity will be hidden inside a cluster. So as I said, Kubernetes is doing lots of other services, which include storage orchestration, secret and configuration management, self-healing, rollout, rollback, automated, service discovery, load balancing, and many more actually. So this is something which Kubernetes is providing, including enhancing your productivity. Deployments for application in the production are faster and simple, lower overhead, improvement in security, increased portability and immutability, and things like that. So guys, did you understand that what is Kubernetes now and why do we need it? All of you, any questions?
Not for now. Thank you.
For me.
Okay, so now next questions we have, and that is like how Kubernetes works. We talked about so many things about the Kubernetes, but how it works actually. So that we need to understand the little bit of architecture. Some of the slides I'm ignoring it because it'll become a long discussions. Okay, so guys, Kubernetes is having the cluster. Okay, you say Kubernetes cluster. In short, you can call it a KX cluster as well. And the Kubernetes clusters, you have a multiple node. Now, when I say node, don't get confused. So this is a VM. It can be physical servers also, but right now let's not talk about physical servers. VM. So Kubernetes will have a multiple node. Node is equal to VM. Now these nodes are playing a two role. Few nodes can be a worker. Few nodes, one node primarily, but you can have a more node also can be master. So same node, one node can play a role of worker, and one node can play a role of master. Now the question is, what is a master node? Next question, what is a worker node? So let me tell you here in a simple way, whatever the important services you need to run Kubernetes cluster, that means Kubernetes application itself is running in the master. Yes, Kubernetes, all major applications are running in the master. So now the question is, what is running in the worker? So guys, worker, you will be running your application. Yes, your application in form of containers. Yes. So, but the next question is, why do we call it master and worker? Because here master manages everything. So whatever the software you have in the master, which manages the entire cluster of the worker, and all the allocations been applied by master to worker. That's the reason say master is the like master, and worker is like a worker who's doing the work on based on the instruction from the master. Simple. So this whole things we call it a Kubernetes cluster. Okay, so master who's in charge and the worker node who's doing the work. Now guys, if you look at this here, who's controlling the master? So basically you have to write some deployment files. It can be in JSON YAML. Basically you will write this, and this is your job. You will write what you want. I want X, Y, Z, whatever you want, put it in YAML file, send it to master, and master will make sure that it is delivering you and allocate the work to the worker. Now if you look at this pictures a little bit node side, you have a few nodes where you have a pod. If you look at this pod image carefully, inside that there's one image which is called container. Now the question is, what is a pod? Question is, what is a container? So container, we know that Docker, we study the container, but why this pod is container is inside a pod in Kubernetes, and what is a pod altogether? So that we need to understand what is a pod. Okay, but right now if you see that Kubernetes deploy the pod in the worker node, and inside a pod you have a container. Okay, look at the perspective. So now let's focus on the master. So how this master server can be set up? So guys, master has to be in Linux 64-bit. Node can be in Windows 2019 or Linux 64-bit, whatever it is. Now how can you make a master? So master, to make a master you need a 4 software. Yes, minimum, few more, but I'm not discussing. You need a 4 software. Because master is very crucial, you can make a multiple masters also. We call it a multi-master HA, high availability. So now if you look at this image, masters required for primarily software to become a master, and the master server which manages the worker server, worker node. And then if you look at this little bit more carefully, in the node, worker node, you have a pod. Left side, you have a pod, one pod, and you have a two containers. Right side, you have a two pod, a multiple pod, and each pod you have a single containers. Understand that way. Okay, that means master can deploy the pod in a node. Master can deploy multiple pod in a node. Each pod you may have one container, each pod you may have a multiple container. What is a pod? We need to discuss, but understand the deployment strategies. So now let's focus on the master. As I said, master, you have a four important software. First software, which you call it API server. What is API server? Guys, if you read this name carefully, API, you understand that nothing great about it. And it's a server. So that means this component, you have hundreds and hundreds of APIs you will find. That's the reason we call it server, right? Now, how do you request this? Of course, it's API, right? API call, you will make it REST API. And basically you have to send a request to YAML or JSON, but yeah, API always consume JSON. So some conversion tools are there. Automatically they will do that. You don't have to worry about it. And this thing. That means anyone who wants to send any request from outside, means you will make a request to API server. Revised. Internal components also, if they want to do something, they will make a request to API server. So that's the reason we call it API server. This we can call it as a control plane, front end to the control plane. Means every communication has to pass through this API server only. So this is the static applications. Okay. Now this stateful cluster store. This is a stateful. Something like you have application and then database, right? So API server is your application and this is your database. So what is this? So you can call it a cluster store. You can call it a database also. So which database? So this is one of the database which is called etcd. Yeah. Someone is asking question. Okay, Hafid, I'm muting you. Okay. So how can we have a persistent storage? So that is powered by etcd. Etcd is one of the kind of database which is again managed by CNCF, and etcd is storing the data in a key and value format like a NoSQL kind of it, but it's lightweight, distributed, scalable, and stuff like that. So if you want to take a backup plan, I mean, if you want to have a backup plan for cluster, you should be having planning for this. Now guys, here third component which we have in the master, which is called controller manager. So what is the controller manager will do at a high level? So basically this will, basically it has a multiple controllers, multiple check, which will keep checking the entire cluster and keep it up to date, the API server and cluster store. So look at the arrow. Controller manager will keep checking the entire cluster, different type of check, and let the API server know about the status of the entire cluster. That's the work. Okay, and controllers always run in a loop. It never stops. The moment it stops, the cluster has certain issues. Next one is scheduler. So what is scheduler? So scheduler basically talk to worker and assign the work. So basically it receives the instruction from the API server and then assign the work to the worker node, and it has a multiple if and buts, something like that, affinity, anti-affinity, constraint, resources, this, that, and all is there. So these four components coming together and making it Kubernetes master. Are you understanding, all of you?
Yeah, I
Okay.
think so.
So guys, yes, this is a summary of the master control plane components, API server, cluster store, scheduler, controller manager, which I have already discussed about it. So I'll just ignore it. Now, little bit more broader. You see the master server, and then you have a right side worker. Worker, you have a multiple pods. Pods, you have a containers. Now, if you see that who's sending the instruction from master server, so that's your laptop. And in your laptop, what you have? kubectl. There's a utility has to be there. kubectl. And then you write YAML or JSON file and then send it to through kubectl to API server. API server will store that all the data in the cluster store. Controller manager will keep saying that, hey, these are the things we have it in cluster, these are the things we don't have it. And based on that, API server will instruct scheduler, hey scheduler, do this one. And the scheduler will choose the worker and deploy the work. It can be updating the work, it can be destroying the work, whatever it is, resources, all this thing. Simple. Now let's discuss about minions. What is minions? See, multiple names. Either you call it a Kubernetes worker or Kubernetes nodes or minions, whatever you want to call it. It's the same way. So how do we make the Kubernetes minions? So guys, Kubernetes minions have a three fundamental software. Okay, three fundamental software. Which are those? So first thing which you need it is kubelet. Yeah. So every machine, I repeat, every machines of Kubernetes cluster, every VMs of the Kubernetes clusters, you need to run this utility. This is the agent. Basically, it has to be running in the cluster. If it is not running, that means cluster has a certain problem. That node is not a part of the cluster. So this is basically has to be run. This is the main Kubernetes agent. This guy only registered node with the cluster, and it keep talking to API server. API server is central, right? Master. And here it instantiated a pod. This guy. Remember, Docker create a container. Kubelet create instantiate a pod. Okay, mind it. And then whatever the work is been done is done, and then report back to the master saying that I have completed this, that, or whatever it is. So that way the master is knowing what exactly you are doing. And this Kubernetes, this utility which is kubelet is running on the port number 10255. Exposes endpoint on 10255. Okay, so this is your agent. Container engine, it can be Docker, Containerd, Rocket, Cryo, so many nowadays so many things. So you understand the Docker well. So second thing, it has to be container engine. And third one, which is to manage the IP address of the pods. Yes, pod I said, not container. And that is called proxy. So proxy is another software which is running in the each worker, okay, which is managing the Kubernetes networking services. So I'm not getting into the detail of each of these, others will become many days of program. So at a high level. So these three components which you need it in order to run the worker. So look at this. This is the one of the good image, I think. Look at the arrow carefully. So you are the one person who send your request. What do you want in the cluster? What resources you want to deploy in the cluster? So you send it to API server through kubectl, if you remember. Kubelet, don't get confused between the kubelet versus kubectl, okay? So kubectl, and after that, it's stored in the etcd. Controller manager keep reporting everything about the infrastructure and man update to API server. Scheduler, based on the request from the API server, schedule the work to the worker. In the worker, you have a three components. Here you have a kubeproxy, a kubelet, and Docker. See that kubeproxy keep talking to API server. Kubelet also keep talking to API server, right? Kubelet instantiate a pod. Docker fill the containers, and then IP address updated by kubeproxy for that particular pod. And this is how that whole relationship works. Are you understanding?
Yes.
Yes.
Yeah. So yeah. So kubelet, container engine, and kubeproxy. There are few more modules are there, softwares which is running in the clusters like a DNS, ingress, and dashboard and all, but it's not so important. But you should know all this. See that from the end user perspective, this is a good image. Remember that the earlier what I was discussing about the Kubernetes from the admin perspective, but how the users will access the containers running the Kubernetes cluster. So this is the image you see from end user. They will hit to the load balancer. Load balancer will hit the IP address of node, and from there it will take you to the containers pod or whatever it is. This is done through the services, not straightforward. We need to understand a little bit of more deep dive into that. Okay, so we understand the master, and then we understand the worker. Now the time has come when we should learn what we are going to write it, right? Because ultimately whatever you write in YAML and JSON, that's your desire. You are going to write it, send it to the through kubectl to API server. So the question is, what are you going to write? What is your desire? What do you want? And then declare it. Whatever your desire, do you know what are the what you can expect from Kubernetes? That's your desire. And declare it. Declare means YAML and JSON. And then send it to Kubernetes API server. Boom. You got it. So you desire 3 pod of Nginx, and you got immediately 3 Nginx pod, which each of these has a containers. And this is what you wanted. The moment you send to API server, you got it the pods, containers. Let's say one node is not down, one node is down. So your desire was earlier 3, actual is 2. So desire is mismatched with the actual. So what will happen? Controller manager, which is running in the master, which will report saying that, hey, we got the only 2 pods. API server will check database. Oh, it was having 3. There's a mismatch. 1 is missing. Hey, scheduler, go ahead and schedule 1 more. 3 was desire. 3 was actual. Desire is match. Now you see that the use of each components, all of you. So this is how it works. So what do you want? What do you want from the Kubernetes? So guys, you want pod. What is pod? You want controllers. You want services. You want storage. You want so many resources. Hundreds of resources you have in the Kubernetes, and that is your exercise. That is your time you need to spend to learn what are the resources we have in Kubernetes, what each resources will do, how do we request that, and then so on. So these are the things you will have to do that. Okay, so these are the fundamental and primary resources. If you want to correlate with let's say AWS pod, you can say compute unit. Okay, computing EC2 controllers. You can correlate with auto scaling group in AWS. If you know services, you can correlate with load balancer. Storage, you can correlate with the different kind of storage we have, right? EBS, uh, S3, all this thing, kind of different storage devices and a driver and all. So yeah, many things are there actually, many features are there. These are the, you see, nodes resource, service resource, ingress resource, endpoint, PVCs, and many more. Namespaces, cron jobs, config map, secrets, limit range, stateful sets, many more actually. Are you understanding, all of you?
Yes.
Yes, yes.
So guys, let's start with the pod. Let's say, let me put it up in this way. When you go to AWS, what do you learn first? You learn EC2, correct? So same way, when you come to the Kubernetes, what do you learn? Pod. So what is a pod? Guys, pod is not anything physical resources. It's basically logical resources. For example, let's understand this way. When you go to the virtual machines, what do? You create a VM. When you go to Docker, what do? You create a container. But when you come to Kubernetes, you should create a pod, right? Simple. So what is a pod? So pod is an atomic unit of scheduling in Kubernetes. Similar way, VM is for the VMware, container is for Docker. So in a pod, you may have a multiple containers. So I must tell you here, pod is an organization, way to organize the containers and manage the resources like CPU, RAM, this, that, and all kind of things. So containers always run inside a pod. Pods can have a multiple containers. So if you remember that in a Docker, I discussed all the namespace resources which was allocated to the container, if you remember that. But in a Kubernetes pod, this get attached to the pod level, not container level. That means whatever the containers you have in the pod, let's say all the network mounts, IPC and everything, all the resources, each container share that. Yes, that means you network attached to the pod level, not the container. Any mount means storage VPC, PVC attached to the pod, not the container. So that means anything which is attached to the pod, every container can share it. So container will become just like a common for, resources will become a common for all the containers. See here, there's one pod, two containers. This concept is called tight coupling. One pod, one containers. This is called loose coupling. Good one. See here, left side you have a 4 containers, and each of these are running Nginx. Good one. One pod, 5 containers of Nginx. Waste, because remember that only one pod, one IP address. You can only run only one Nginx. You can call. So 4 Nginx is getting wastage. Okay. The first container of that pod, we call it a main container. Second container of the pod, we call it a sidecar container. You see that in this image, pods are atomic. All the resources within associated of the pod to shared in the containers, and it can scale. Pod can scale. It can become 1 to 2000. So now these are the life cycle of the pod. So pod, when you scale, the pod will be in a pending state, running state, succeeded and failed. This is called life cycle. What is this? If you look at this very carefully, inside a pod which is in pending, the container is not running. So that's the reason pod is pending. Second, the container is running, so pod is running. And then container got failed or succeeded, so pods also get failed and succeeded. So remember that pod cannot be created. It can be pending, running, succeeded and failed. That's all, like that. Now look, if you look at this here, pod 1, you have 2 containers. One container is running on 80 port, second container is running on 5000 port. How can you access? You can access that through the pod IP address and then container port number from outside. Usually one container, one application is a ideal actually. Okay. See that each of these containers, they talk to each other through the pod network. That means in a Kubernetes, they laid out one network. This is called pod network. Okay, container network. So all the containers, they talk through the pod network only. Okay. Look at this here. If you have 2 containers in a pod, they want to talk to each other, you can use the local host. Yes, you can use the local host. But from outside, IP address of the pod and the container of the port number, port of the container. So that is how it can be done. Are you understanding, all of you, right?
Yes, sir.
So guys, what is pod? So guys, pod is having one or more containers. Pods can be your application or it can be service. Now what is service? I need to discuss about this. Okay, pod is a most basic unit of work in Kubernetes. Pod is a basic unit of scheduling in Kubernetes. Pods are ephemeral. No pods is ever ready to deploy. That means, see, I'll tell you in a simple way. If you deploy the pod and then pod is gone, and if you say, Rajesh, I need the same pod, I say it's impossible. Okay, remember that there's no start or stop concept in that pod. Container, we had it. Pod have no start stop concept. You cannot get it. So if the pod is gone, gone. I can get you similar pod, not the same pod. There's a difference. Similar versus same. Please understand that. Pod is atomicity. They are there or not. Simple. What is the job of Kubernetes? So job of Kubernetes to run your pod. That's all. Maintain their states. It should be up and running. Health and some checks which you applied through the deployment file. So pod is running. Pod has a container. Container is running in the multiple node. Kubernetes is managing it, and that is what you wanted, to run thousands of containers in a multiple host, and Kubernetes is able to manage with the help of pod concept. And that is why we have a pod. Did you understand, all of you?
Yes.
Cool. Okay. So now, before discussing some other topics, we need to do the deployment of the.
Have any issues with our channel membership, you can drop an email to us at contact@devopsschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.